Good afternoon, everyone. I'm Ira Porwal, and I'm currently pursuing Masters in Technology, and I'm in sixth sem from International Institute of Professional Studies, the AVB. And today we will be seeing our question paper, assignment test paper number 3, and we will be seeing the solutions along with the concepts. So the very first question we have is in matrix multiplication, in Strassen's matrix multiplication, the number of multiplications needed to multiply a 2 by 2 matrix. So the answer for this would be 6, which is answer B. The Huffman, now question number 2 is the Huffman code is a type of. So option for this would be a lossless compression of an algorithm. The Huffman algorithm is used for compressing a message or a code, but here when we compress, so we are just reducing the size of our code and whatever message we are sending. There is no any kind of data loss. So it is lossless compression algorithm. Now question number 3 is in Kruskal's algorithm, what is the time complexity for sorting the edges of the graph? So time complexity would be option B, which is O of n log n. In Kruskal's algorithm, the time complexity is O of n log n. Now question number 4 is in Prim's algorithm. In Prim's algorithm, what is the time complexity for finding the minimum weight edge from a vertex? So the answer for question 4 would be A, which is O of n. Let me just mark it. Question number 5 is in DFS, which is depth first search, can be used to find. So it is used to find the longest path between the two nodes in the graph. So here we will see option B, which says exactly the same, to find the longest path between the two nodes in a graph. Now question number 5 is just opposite of that, which is breadth first search, in which we have to find the shortest path. So BFS, question number 6, BFS. So answer for question number 6 would be A, which is the shortest path between the two nodes in the graph, which is BF algorithm. Using BFS algorithm, we can do so. Now question number 7 is dynamic programming can be used to solve problems that exhibit. So the option is A, which is the problems that exhibit optimal substructure and overlapping subproblems. So optimal solution, for getting our optimal solution for our problem, we use dynamic programming. Now question number 8 is the matrix chain multiplication problem can be solved using. So the matrix chain multiplication problem can be solved using dynamic programming. So here option A for question number 8, which is dynamic programming. Now question number 9, the longest common subsequence problem can be solved using. So the longest common subsequence problem can be solved using same, which is option A, dynamic programming. Question number 10 is in Strassen's algorithm, the matrices to be multiplied are divided into. So in Strassen's algorithm, the matrices to be multiplied are divided into two equal parts. So the option will be B, which is two equal parts. Now question number 11, the running time of Strassen's algorithm is. So the running time of Strassen's algorithm is O of n to the power c 2.81. So which is option number C. Now question number 12 is the Huffman code is codes are prefix code, which means that the Huffman codes are the prefix codes, which so answer for this would be no code is a prefix of any other code. Now let us see question number 13. So solution for question number 12 would be A. Let us mark here A, which is no code is a prefix of any other code. Now question number 13 is on the top. So the question number 13 says the minimum number of bits required to represent the symbols in a set using a Huffman code is. So the minimum number of symbols would be option number B, which is less than the number of symbols. So for Question number 13 would be the option B, which is the less than the number of symbols. Now question number 14, what is the time complexity of a standard matrix multiplication algorithm? So the time complexity for a standard matrix multiplication is O of n to the power 3, which is option number D. Now, in Strasson's matrix algorithm, what is the base case for the recursive algorithm? So the base case would be symbols with high probability. So the answer would be, this is answer number B, symbols with higher probability. Now question number 17, in Kruskal's algorithm, how many times are the edges of the graph sorted? So in Kruskal's algorithm, the number of times the edges are sorted is only once. Now question number 18 is, Prim's algorithm can be used to find the minimum spanning tree of, Prim's algorithm, we can find the minimum spanning tree of undirected graphs. In this we cannot find the minimum spanning tree for the directed graphs, so option will be undirected graphs. Now question number 19, question number 19 is the time complexity of BFS, which is breadth first search, is, so the time complexity for BFS is O to the power n, which is option number A, O to the power n, and 20, which is the time complexity for DFS, which is depth first search. So the time complexity for depth first search would be same, that is O to the power n, which is option number A. Now let us see question number 21. What is the time complexity for the dynamic programming approach for solving the longest common subsequence problem? So the answer for this would be O to the power O of n to the power 2, which is option number B. Now question number 22, in the matrix chain multiplication problem, the number of matrices to be multiplied is, so in matrix chain multiplication, the number of matrices to be multiplied, depends upon given as an input to the algorithm. So option A. Now 23, what is the time complexity of the dynamic programming approach for solving the matrix chain multiplication? So the answer is O of n to the power 3, which is option number D. Let us see another set. Now question number 24 is, what is the following algorithms uses a greedy approach? Which of the following algorithm uses a greedy approach? So the algorithms using the greedy approach is Kruskal's algorithm. The option A, which is Kruskal's algorithm, uses a greedy approach to solving. Question number 25, the longest common subsequence problem can be used to solve. So the longest common subsequence problem can be used to solve DNA sequencing problems, which is option number B, DNA sequencing problems. Now the question number 26, the running time of Strasson's algorithm is faster than the standard matrix multiplication algorithm for matrices of size. So the answer for 26 would be 4 by 4. So can be used to solve problems of matrices of size 4 by 4. Now question number 27, in the Huffman code, the average length of a code word is, so the average length of the code word should be less than the number of symbols. जितने number of symbols है, suppose we have 20 number of symbols, so the average length of code should be less than that. Now it can be any number, it depends on the code itself. Now question number 28, what is the time complexity of the dynamic programming approach to solve the matrix chain multiplication problem? So the time complexity for solving the dynamic programming approach for matrix chain multiplication would be n to the power 2, which is O of n to the power 2. Now, question number 29 is, in the dynamic programming, what is the maximum number of sub-problems that need to be solved in dynamic programming approach for the matrix chain multiplications problem? Let me just scroll it up. Matrix chain multiplication problem for n matrices. So the answer for 29 would be option B, which is n. Now let us see question number 30. In the dynamic programming approach to solve the longest common subsequence problem, what is the recurrence relation used to calculate the length of the LCS? So, longest common subsequence. To calculate the length of longest common subsequence, so our option would be B. This approach can be used. Now 31, in the dynamic programming approach to solve the longest common subsequence problem, what is the time complexity to print the longest common subsequence? So the time complexity for printing the longest common subsequence would be O of n. Now question number 32, what is the time complexity of the dynamic programming approach to solve the matrix chain multiplication problem for a given sequence of n matrices? So the option would be O of n to the power 3, which is option number B, which is O of n to the power 3. Question number 34. Question number 34. Which of the following algorithms can be used to solve the longest common subsequence problem? So the dynamic programming we can use for solving the longest common subsequence problem. So answer would be option D, which is dynamic programming for solving longest common subsequence. Now 35, which of the algorithm can be used to solve the matrix chain multiplication problem? So to solve the matrix chain multiplication problem, we all know that the algorithm we will be using would be same, which is dynamic programming, option D. Now question number 36 is, in the dynamic programming approach to solve the matrix chain multiplication problem, what is the minimum number of scalar multiplications required to multiply n matrices? So to multiply n matrices, we will be needing option number B, which is m of 0 and minus 1. Now question number 37. In the dynamic programming approach to solve the matrix chain multiplication problem, what is the minimum number of scalar multiplications required? So the minimum number of scalar multiplications required, this would be also same, which is m of 0 and minus 1, which is option number B. Now let us see question number 38, 39 and 40. So question number 38 is, which of the following is not a sub-problem of the dynamic programming approach to solve the longest common subsequence problem? So the answer for question number 38 would be option number D, which is LCS I plus 1 J plus 1. Now question number 39. Let me scroll it down. Question number 39 is, the dynamic programming approach to solve the longest common subsequence problem has a time complexity of, so it has a time complexity of O of n to the power 2. So which is our option number A, which is O of n to the power 2. Now what is the difference? The last question, which is for question number 40, is, what is the difference between Prim's algorithm and Kruskal's algorithm for finding the minimum spanning tree of a graph? So the answer for this would be all of the above, and let us read the options for more clearance. So option number, let me highlight option number D, which is all of the above. Option number A says that Prim's algorithm starts with an arbitrary node and adds the shortest edge from the set of available edges, while Kruskal's algorithm starts with the shortest edge and adds edges in increasing order of their weight. Option number B, Prim's algorithm uses a priority queue to select the next stage of the to add the tree, while Kruskal's algorithm uses a disjoint set data structure to maintain the set of connected components. Prim's algorithm always produces a connected tree, while Kruskal's algorithm may produce a forest of disconnected trees. So this is how all the options are correct, and our solution would be so the answer for our problem would be all of the above. Um, and thank you for watching the video. Hope this was helpful to you. Thank you.